The last pressure variable that we're going to look at is temperature. So just a quick reminder, STP is standard temperature and pressure. So standard pressure is 1 atmosphere or 760 millimeters of mercury, and standard temperature is 273 Kelvin. When we collected our data from our pressure exploration, we saw that there was a direct relationship between pressure and temperature. When the temperature went up, the pressure also went up. When the temperature went down, the pressure went down. When we initially graphed this, we measured temperature in degrees Celsius. So we saw that the line intersected with our y-axis somewhere up here. Now this causes a bit of a problem because when we go to do math, we'd be dealing with a zero temperature or negative temperature, and we can't have a negative pressure, or we could have a zero pressure, but it would give us incorrect information. So what we have to do is we have to adjust our temperature scale to something called Kelvin. And Kelvin is simply moving this line over and setting zero pressure at absolute zero, which is 0 Kelvin. To convert between degrees Celsius and temperature in Kelvin, Kelvin is your degrees Celsius plus 273. So say it's the middle of summer and it's 98 degrees outside, and you wanted to know what that was in Kelvin, you do 98 plus 273, and that would get you your temperature in Kelvin. It's not degrees Kelvin, it's just Kelvin. All we did was slide this line over so that our y-intersect is at 0. Still, it doesn't affect the relationship. If we have a high temperature, it means we have, that should say high pressure, not low pressure. High temperature is high pressure, and low temperature is a low pressure. Okay, let's look at our first example problem. You have a sealed container at room temperature, 293 Kelvin. The pressure is 0.96 atmospheres. What will the pressure be if you increase the temperature by 50 Kelvin? So we put in our information, so volume and our number of particles are constant. Our initial temperature is 293 Kelvin. Our initial pressure is 0.96 atmospheres. If we were increasing the temperature by 50, so if I do 293 plus 50, I get 343 Kelvin. And I want to know what my pressure is. Okay, so if my temperature is going up, what's my pressure going to do? Well, my pressure is going to go up as well. So we write pressure first, because that's the thing that we're changing. Set up my factor for temperatures. If I want pressure to go up, I need my bigger number on the top, my smaller number on the bottom. My Kelvin units go away. So now I just do 0.96 times 343 divided by 293, and I get 1.12 atmospheres for my final pressure. Okay, let's look at one that's a little bit more tricky. You have a gas cylinder outside when the temperature is 2 degrees Celsius. You bring it inside where the temperature is 23 degrees Celsius. What will the pressure be if the initial pressure is 700 millimeters of mercury? So again, volume and number of particles are constant, so we're not going to worry about those. We have these in Celsius, so the first thing we have to do is convert them to Kelvin. So I have my 2 degrees Celsius plus 273 gets me 275 Kelvin as my initial temperature. Notice I did that before I even started writing it in the box. And then I have 23 degrees Celsius plus 273 gets me 296 Kelvin. So that's my final. And my initial pressure is 700 millimeters of mercury. Okay, so what did my temperature do? My temperature went up. So my pressure is also going to go up. So I have 700 millimeters of mercury. Since my pressure is going up, I need my temperature to be on the top. My big temperature to be on the top, 296. And then 275 is going to go on the bottom. And then I do 700 times 296 divided by 275.
and I get 753 millimeters of mercury
as my final pressure.